So my first instinct when I see this question, as I would have done if this were an equal sign, okay, so if this is 2 over x minus 5 equals 10, the first thing I do is multiply both sides by the x minus 5. It's not. And so what we want to remember is if I try to do this, if I try to multiply both sides by x minus 5, when I have an inequality, if my term that I'm multiplying or dividing by is negative, I have to flip my sign. Because I don't know what x minus 5 is, if I choose to try to solve this way, then I have to handle it as two separate cases. Case 1 is where x minus 5 is positive. Case 2 would be where x minus 5 is negative. And we have to solve the problem twice. That's doable. Sorry to set here, but we must flip the less than sign if x minus 5 is less than 0. So instead we're going to deal with this a different way. Now the case is a possibility. It works fine for this first problem because it's a fairly small problem. Solve each case separately, you get the same answer, of course. We don't want to do that with a bigger problem because at some point we end up with a situation where we have to multiply by more than one term, and we end up with potentially 3 or 4 different cases depending on how obvious negatives and positives become. So instead, sort of slide up to here, my solution will be to subtract the 10, get all the information on one side. I can always subtract and add across a less than or greater than sign without worrying about flipping. The next thing to deal with then is what's on the left side, so this stuff. The only way I can simplify something like this is by finding a common denominator. The common denominator is x minus 5 here, and so I've rewritten my second expression, the 10, the minus 10, as a fraction with that same denominator. Once we have a common denominator, of course we can just write it as a single fraction. That's the idea of fractions. If I have 1/2 plus 2/3, once I write it as 1/6 and 4/6, the common denominator allows me to add the top and leave the bottom alone. Okay, so doing the same thing here, common denominator is the x minus 5 now. I can write it as a single fraction, and now I'm just going to basically go about solving things. On top, I can expand the top a little bit. I can then simplify the top a little bit. Okay, so multiply the negative 10 through, add the 50 to the 2, and then what I'm interested in is what do I know about that as an expression? So if I think about it in terms of f at x being that, this is sort of the thing we've been graphing for the last week or so. Key features from that, I have a vertical asymptote when x is 5, and I have a y-intercept when x is 5.2. Okay, so you can sort of see the solution in each case. The keys are, of course, when the top is 0, and when the bottom is 0. Once we have this in kind of a factored form, although it's a pretty simple factored form, obviously, we can find those key features. And then from there, we know those will be my zeros, and in between or around those is where the different options will occur. Numbers that are not 5 and 5.2 will either be negative, or will either give negatives, give positives, and we just have to figure out which is which. And so, without going too far here, dealing with the 52 minus 10x, I just kind of rewrote this down here for my own purposes. I need to test a value in each of these areas. In area 1, I picked the 0, again, just because. I just picked it because it was a nice number to work with. When I plug the 0 in, I get 52 minus 0 on top, 0 minus negative 5 on the bottom. Again, all that really matters is, do I have positives or negatives? So positive, negative, overall that means my whole expression will be negative. Test 5.1, same idea. I end up with a positive over positive. Test x equals 10. And again, I just picked these numbers because they were nice to look at. Because they're nice to work with, is what I'm trying to say. 5.1 happens to be obviously between 5 and 5.2. The 0 and the 10 are just easy numbers to work with. And so, last statement, basically, just have to figure out what my solution is. If I sort of slide back here, the question that I was working with was this one. And so I need to know when the 52 minus 10x over x minus 5 is less than 0. That's what I'm interested in specifically. And of course that happens in this area here and this area here when x was in region 1, which is less than 5, and when x was in region 3, which is greater than 5.2. And we'll sort of note, because this was a less than sign and not a less than or equal to, the actual zeros, the 5 and the 5.2, are not in my solution. Go through a little bit bigger one here, but I'll go through it a little bit more quickly. So this is my initial expression. Again, sort of if I tried to multiply here by x minus 3 or by x minus 6 to eliminate my denominators, I end up with multiple cases. The case where x minus 3 is positive, the case where x minus 6 is positive, negative, and so on and so forth. So instead, I will subtract everything to one side. I don't care which side, it just seems like working from the left is more natural to me. So I subtract the whole expression over. Common denominators, I will need to have an x minus 3 and an x minus 6 in each term. And so I multiply the first term by the x minus 6 that was in the second term, multiply the second term by the x minus 3 from the first term. Now it's a bit of work to expand. So multiplying through this section here, I get this here. And if you need to, try that on your own to make sure it worked. Same sort of thing over here. Multiply through that, and I get this right here. And again, try it on your own if you need to. Notice I kept the negative sign outside my brackets. I'll deal with it in a moment. I just want to make sure I don't go too far, do too much, so that I make a mistake. It's a long question. I don't want to make a silly mistake with a negative sign to mess myself up. Going forward now, obviously the reds are the two things. I just simplified each of the middle terms, and then deal with the negative sign now. This is saying I want to subtract each of these. Subtract x squared, I get negative x squared. Subtract negative 2x, I get positive 2x. Subtract negative 3, I get positive 3. Simplify just a little bit now. X squared minus x squared is 0x squared. Negative 10x plus 2x is negative 8x, sorry. 24 plus 3 is 27. Okay, so same sort of thing now. Key points are when the top is 0 and the bottom is 0. Those will always be my keys. Top equals 0, bottom equals 0. Those are my keys. And so, off to the side, vertical asymptotes 3 and 6. And y-intercept is when the top is 0. So I sort of did that over there. Let the whole thing equal 0. And when we simplify, we get 27 over 8, which I found to be 3.375. So my number line then, sort of finishing up, I have 4 different regions, less than 3, between between, and greater than 6. And now I'm just going to do, again, test a value in each of the areas to figure out what my final answer is. I tested 0 over here, tested 3.2 because it was clearly in here, 5 in here, and 10 out here. Again, mostly because they're fairly nice numbers, the 3.2 because it's clearly between the two numbers that I'm worried about. And when I use I'm using this to test in, so I get a positive number when the 0 on top, I get a negative here, negative here, negative here, and so there's my positive, negative, negative, which overall is positive. Stop. And then again, same sort of thing with the other two. 3.2 tested, we get a positive, positive, negative. 5 tested, negative, positive, negative, and negative, positive, positive. So at the very end here, I'm looking for numbers which were, kind of going back to this point, greater than or equal to 0. Again, greater than or equal to. And so the numbers in this area, area 1, were all positive. The 3 itself, though, we want to remember, was one of the vertical asymptotes. Slide this up a little bit. So 3 cannot be involved in my solution. So my answer is x is less than 3. The other positive area is this one down here. And it's between the negative 3.375 and the 6. The negative positive 3.375 and the 6. This number is perfectly legitimate. It gave me a 0 on top. Zeros on top, of course, are fine. So when I write my solution, and of course, if you wanted to put 3.375 is less than or equal to x less than 6, that's fine as well. The 6, though, because it's a vertical asymptote, is not part of my solution. Okay, so there's a lot there. Combining the algebra stuff that we did with equalities and kind of the concepts of the graph, recognizing where those key features are. We'll be working on it for a few days. If you need a little practice with fractions, like I said, I'll try to find something to put up there first, because obviously the common denominator idea is going to be pretty important here to be able to solve these. All right, I'm going to stop it there, and as always, you'll have to ask questions, and we'll see where we're going from here.